right, so like I said, section 11.7 is the last section in the chapter and the last section that we're going to do for semester 2. So go ahead and put the title on your flap, which is Circles in the Coordinate Plane. And so when you get to Algebra 2 next year, you're going to be graphing not only circles, but a stretched circle that's called an ellipse. And then you're going to be graphing some what look kind of like parabolas, but they face either right and left or up and down. They're called ellipses. Didn't I just say that? Yes. The ellipses and the hyperbolas, and then some more parabolas. Parabolas you probably did in Algebra 1. You'll see some more of those next year. But the main one that you'll start with is circles. So we're just going to do a brief introduction to it. And the formula looks like this. You're going to have x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. And so if you have an equation that's in this form, you'll look at it and you'll be able to figure out from the numbers that are plugged in two things. What do you think the r stands for? Radius. The r is going to be the radius. And then you're going to have a number right here where the h is at, and a number right here where the k is at, and that's going to be your center, okay? Which only leaves two variables. That would be the x and the y. So the x and the y are going to stay in your equation, kind of like the equation of line, y equals mx plus b. Your y and your x stay in there, right? And then you have usually a fraction in for your m, and then some other positive or negative number in for your b. Okay, so this is kind of the same. You're going to have the x and the y still in there, and then you're going to be able to look at that and figure out how to graph a circle. All right, example number 1, we're going to write an equation whose center is going to be at j, which is at right around there, 2, negative 3, and has a radius of 4 units. All right, we already said that the r is going to be the radius. So underneath this 4, I'm going to write an r. And then wherever the center's at, the first number is going to be the h, and the second number is going to be the k. Okay? Yeah? In your foldable? Probably the top. It doesn't really matter though where. All right. So what we're going to do is we're going to start with the equation. We're going to start with the x minus h, quantity squared, plus the y minus k, quantity squared, equal to the r squared. And the first couple problems you do like this, you're probably going to want to start just like I am. Start with the equation, and then underneath each of the 3 things you need to plug in for, you're going to write what those numbers are. For instance, underneath the h, you're going to write a what? 2. Underneath the k, you're going to write a what? Underneath the r, you're going to write a what? 4. Okay? Everything else, you're going to fill in. So this is going to be x minus 2, quantity squared, plus y minus negative 3, quantity squared, equals 4 squared. Now we're going to simplify. So 4 squared is obviously what? 16. And the other tricky thing here is we have minus, minus. When you have minus, minus, what should you do? Do plus, plus. So this is going to become y plus 3 squared. And this one doesn't, this term right here doesn't have anything to simplify. So we're just going to leave it as x minus 2 quantity squared. And that is the answer. If someone were to look at that, they would be able to graph a circle right from that. Okay, and you will too. All right, example number 2. We're going to write an equation again. And I'm going to give you the center. It's at 1, -8. But in this time, instead of giving you the radius, I'm actually going to give you another point. So it's going to pass through 6, 4. Now, if we were using the coordinate plane for this, you could graph those 2 points and you could kind of see that they're not in a straight line. They're not right and left of each other. They're not up and down from each other. They're making a slanted line. So you wouldn't even be able to get the length of that radius. You would need to use something called the distance formula. Distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And with this distance formula, you want to take those 4 numbers that were given with those 2 points and plug them into the right spot. So this is going to be our x1 and our y1. This is going to be our x2 and our y2. So we're going to have the square root of 6 minus 1, quantity squared, plus 4 minus -8, quantity squared. Now we're going to simplify. Anybody know what 6 minus 1 is? 5. Oh, good. You guys are quite good. And then we've got another minus minus. Minus minus is what? Plus. So what's 4 plus 8? 12. So we've got 12 squared. And we can simplify this even more. 5 squared is what? 25. And 12 squared is 144. So take your calculator, add those 2 together. You should get the square root of 169. We like 169. Why? Because it's perfect square, right? It's not going to get us some weird decimal. What's the square root of 169? 13. So that means that 13 is our radius. Okay? So using the radius and the center up here, that's going to be our h and our k. We're going to have x minus 1, quantity squared, because that's our h, plus y plus 8, quantity squared, that's our k, equals, and then we want to take 13 and square it, right? It's just the number that we just square rooted, so it's 169. That's our r squared. All right, any questions on example number 2? Yeah.
Oh, I was wondering if I accept that right.
I'm sorry?
Never.
You got it?
Yeah.
Okay. I'm going to move this up to see it in just a second. There it is. All right, example number 3, we're going to graph. We're going to graph the following equation, x squared plus y squared equals 16. So with your graph paper, you want to label the first box, example number 3. And we're going to put it on there in just a second as soon as we figure out the 2 pieces of information that we need. We need the center and we need the radius, right? So, might be easiest to start with the radius, right? We have 16. Is that our radius? No. What's being squared to get 16 is our radius. What's being squared to get 16? 4. So I'm going to write 4 squared. And then this part's a little bit tricky because in the equation that I showed you, there should be something being added or subtracted here, right? And there should be something that should be added or subtracted right here. Jacob,
Is it 0?
It is. It's 0. So I'm going to rewrite this as x minus 0, quantity squared, plus y minus 0, quantity squared. Do I have to put plus on both of them? Yeah, it wouldn't matter. That just means our center is going to be where? 0, 0. What we call the origin, right? And then our radius is 4. Okay, so you always want to start with the center. 0, 0 is easy to find. It's right in the center here, right? Okay, there's our center. Now, the radius always is the same length or distance no matter which direction you go, right? So we're going to go all 4 directions, 4 units. So we're going to start at the origin and we're going to count 1, 2, 3, 4 to the right and put a point. Then we're going to go back to that center and we're going to go 4 to the left. 1, 2, 3, 4, put a point. Then we're going to go back to that center and now we're going to go up 4. 1, 2, 3, 4. Then we're going to go back to the origin and count down 4. 1, 2, 3, 4. And we've got 4 points around that center. They're all equidistant. And so we're going to make them into a circle. There's 4 points. So it kind of looks like we want to make a square, but don't make a square. You want to make a circle. So you might have to go around a couple times to make it smooth, but it's actually pretty easy to do with a pencil. It's kind of hard to do with a marker or a pen, but if you have a pencil, yours will probably turn out better than mine. If it doesn't turn out quite right your first time around, go around a couple times until it looks circular. All right, example number 4. We're going to graph this one again. We've got x minus 3 quantity squared plus y plus 4 quantity squared equals 9. So we're going to label our second box example number 4. And first thing we want to do is find that center. Anybody think they know the center? What is it, Jacob? Perfect. 3, -4. Everybody agree with him? Yeah. Okay. How about the radius? 3, right? Because this is 3 squared. That means our radius is 3. Okay? So always start with your center. So to get to the center at 3, -4, we're going to go 3 to the right. 1, 2, 3. And down 4 because that's negative. 1, 2, 3, 4. And there's our center. Now this one's a little bit trickier because it's not centered at the origin. So every time we go back, we have to go back to that center, not to 0, 0. So from here, we're going to go 3 to the right. 1, 2, 3. Put a point. Go back to the center. Go 3 to the left. 1, 2, 3. Put a point. Go back to the center. Go up 1, 2, 3. Put a point. Go back to the center. Go down 1, 2, 3. And there's your 4 points. And you're going to connect them as smoothly as you can. Not bad.